Hello, today we are going to be talking about exponents. So what is an exponent? An exponent refers to how many times a number is multiplied by itself. So if we have x to the m, that is saying that we are going to take x times x times x times x, that m times. So if we wanted to look at a numeric value, then if we have 2 to the second power, that's saying 2 multiplied by 2. If we have 4 to the sixth power, that's saying 4 times 4 times 4 times 4 times 4 times 4. So 4 6 times. Now that we understand what exponents are, let's look at a few rules that will help us simplify problems that have exponents in them. Looking at our first rule, we have b to the d power multiplied by b to the c power. Note that when the bases are the same is only when this rule can be applied. So if you have b to the d power multiplied by b to the c power, we can rewrite that as b to the power of d plus c. So if we look at an example, let's say we have 2 to the power of 2 multiplied by 2 to the power of 3, then that's going to equal 2 to the power of 5. And so we see if we did 2 to the power of 2, and then we also did multiplied by the quantity of 2 to the power of 3, that we're going to get the exact same answer. So 2 to the power of 5 is equal to 32. Then if we take 2 to the second power, that's going to be 4. And if we take 2 to the third power, that's going to be 8. And we know that 4 times 8 is equal to 32. And these are the same. So it doesn't matter which way you want to solve them. However, if you are dealing with variables, when simplifying a problem, that's when these rules will come in handy. Looking at our next rule, we have b to the d power, and that quantity raised to the c power. So in this case, we can rewrite that as b times d to the c. This c is being distributed inside to that b and d. So therefore, we have b raised to the d times c power. So if we use a numerical example, we could take 2 squared, and then that raised to the third power, which then could be rewritten as 2 to the 6th, which is equal to 64. Or we can do 2 times 2, which is 4, that raised to the third power, which is equal to 4 times 4 times 4. 4 times 4 is 16. 16 times 4, 64. So again, the exact same answer. All right, looking at our next rule, we have b times d and that quantity raised to the c power. So similar to our last example, we can take this c and distribute it into each item within that parentheses, and so that can be rewritten as b to the c power multiplied by d to the c power. If we continue on with division, so we take b divided by d and that raised to the c power. Again, we're going to take the c and we're going to apply it to every single term that is in that quantity. And so therefore that can be rewritten as b to the c over d to the c. And if we wanted to use a numeric example on this one as well, we can do 2 over 3 raised to the fourth power, and that can be rewritten as 2 to the 4 over 3 to the 4. Okay, looking at our next law, we have b to the d power divided by b to the c power. So if we have b to the d power divided by b to the c power, and d is greater than c, then we can subtract c from d. However, if we have b to the d power divided by b to the c power, and c is greater than d, then we have to move down to the larger number, which in this case is b to the c. Therefore, we rewrite this as 1 over b c minus d. So let's take a look at an example at both of those. If we have 2 to the 7th power over 2 to the 6th power, then we know that 7 is larger than 6, so we can rewrite this as 2 to the 7 minus 6, which is equal to 2 to the 1, which is equal to 2. However, if we have 2 to the 6th power over 2 to the 7th power, we know that 7's larger. Therefore, we need to rewrite it as 1 over 2 to the 1, which is equal to 1/2. Again, you need to be cognizant of where the larger number is if you have the same base with different exponents, because that will determine if it stays in the numerator or moves down to the denominator. And our last rules that we're going to talk about are negative exponents. So if you have x to the negative 1, then that can be rewritten as 1 over x. And so a negative sign. Similarly, if you have 1 over x to the negative 1 power, that can be rewritten as x. So an easy way to think about this is if you have a negative exponent, then you just need to switch it to either the numerator or the denominator. So in this example, x to the negative 6, we know that's negative exponent. That's in the numerator already. Therefore, we need to write it as if it were in the denominator. Similarly, if we had 1 over z to the negative 5 in the denominator, we just write it z to the 5th in the numerator. So with negatives in the exponent, all you need to do is switch them to either the numerator or the denominator. Okay, let's look at some examples. Okay, so let's look at our first example. We have 2x squared, and that quantity squared multiplied by x to the 4th. Okay, so we have a couple things going on here. One, we have a quantity squared, right? And then we have x to the 4th being multiplied by that. All right, from the rule, we know that this power exponent gets brought in to both variables. So let's do that. So that states that 2 squared, so that states 2 squared x to the 4th, because in this one we have x squared squared, and by our rule, that is x 2 times 2, because they're being multiplied, so that's our rule, so that's how we get 4, and then we're still multiplying that by x to the 4th. So with this, we have 2 times 2, which is 4, x to the 4th multiplied by x to the 4th. Now our last rule states if we have xa multiplied by xb, then that's going to equal xa plus b. So from this rule, we have 4x to the 4, and then we're going to add these together because it's the same base, so that becomes plus 4, and therefore this becomes 4x to the 8th, and that is how you simplify this problem. Let's look at our next example. Okay, so we have this problem that looks really complicated. However, if we follow our rules, we should be just fine. So we have x to the 7th multiplied by y to the 6th divided by x to the 4th multiplied by y to the 7th. Now that quantity is multiplied by y, and then that whole value is squared. We take these one step at a time. Let's work with the x first. So by the rule, we know that if we have x a over xb, depending on which one's greater, so in this case, a is greater than b, so therefore it's going to be x a minus b, right? So if that's the case, we have x 7 minus 4, and then we have y to the 6th over y to the 7th multiplied by y, and then that value squared. So with x 7 minus 4, that becomes x to the 3. Now let's look at y. Well, in this case, y, we have our rule that states when you have xa and xb, and b is greater than a, then this becomes 1 over xb minus a. So all we need to do is subtract from 7. All right, and so we have that multiplied by y, and that quantity is squared. We can rewrite this as x cubed over y. 7 minus 6 is 1, so it's y to the 1, which is y, and then multiply it by y, and then that quantity is squared. So we see here that if we rewrite it, we have x cubed y over y, and then that quantity squared. Well, we know anything divided by itself is 1, right? 3 divided by 3 is equal to 1. 2 divided by 2 is equal to 1. 50 divided by 50 is equal to 1. And so we know anything divided by itself is equal to 1. Therefore, we are just going to cross this out because we know that this is equal to 1, and x cubed times 1 equals x cubed, right? We are left with x cubed squared. And then with our rule of exponents with exponents, we know that if we have xa to the b, that's equal to xa times b. Therefore, we need to take x 3 times 2, and that's going to be equal to x to the 6th. And that is how you simplify this problem down. All right, let's look at our final example. All right, looking at our final problem, we're going to combine everything that we've learned and try to solve this problem. I want you to pause the video, solve it for yourself, and when you think you have the answer, press play and let's see if we get the same answer. Okay, so I see that we could combine these terms and these terms. From our rules, if we have the same base, all we need to do is add the exponents together. So that's what I'm going to start by doing. And we have negative 7 plus 4 is x to the negative 3. And then this multiplied by y. This raised to this 2 power. And then we divide that by, and then I'm going to bring this y out in front just because I like to see it out in front and I don't want to miss it. So we have that y there, and then we do 4 plus 2, which is y to the 6, and then we have our c value there. Next, we see that we have this quantity raised to the 2 power, and by our law of exponents, we're able to distribute this 2 to each of the values inside. And so how we do that is by multiplication. So this can be rewritten as x to the negative 6, because 2 times negative 3 is negative 6, and then y squared. And then this is divided by y, and we have y to the 6 plus c. Okay, so now we see that we have division, and from our rule, we know that we have to look at the exponents because the bases are the same. We see that the exponent in the numerator is the highest, so that means we're going to bring the y up to the numerator, and we do subtraction, and so with that we would do 2 minus 1, which is equal to 1, and anything raised to the 1 power is that number itself. And so what we would have after we rewrite this is x to the negative 6 y divided by y to the 6 plus c. Okay, now the last thing we see is this x to the negative 6, and by our law of exponents and negative signs, we know that if it's in the numerator, we just need to move it down to the denominator, and it gets rid of that negative sign. And so let's do that. And so this can be rewritten as y over x to the 6 multiplied by your quantity y to the 6 plus c. And this is our answer because we can't go down any further. Hopefully this quantity here didn't confuse you. Because this is plus, this isn't multiplication, this isn't division, therefore we can't simplify this out any further. This y here in the numerator can't just go specifically to this y here because this y is connected to the c here. So it's kind of a tricky problem because we do have this addition here. But again, because our rules are specific to multiplication, division, and other exponents, we know that none of those rules apply, and that leaves us with this final answer here. How did you do? Did you get it right? Well, I hope you did, and I hope you learned a lot from this video. If you did, give it a like, and we'll see you next time.